So hello everyone, this is lecture 31 for the quantum mechanics. In this lecture we will study about the potential barrier and the quantum tunneling. In the last lecture what we studied the step potential, which look like this. Means there is this barrier of V naught potential. And we studied about the transmission coefficient and the reflection coefficients. And we studied there that if the total energy is less than V naught, then there still be the probability of particle to be found here after the barrier. And this probability will decrease like this curve. And now this is a infinite barrier, that's why it is a step potential. But if we make this finite, then it will turn out to be potential barrier, which we will study today. Then there will be particle, means if this tending to zero probability is ended here, means here we made the barrier, then particle can be find it here also, and this thing is called the tunneling. So we'll study about this also today. Tunneling is a very fascinating thing. So let's start. So we'll do the same thing as we did in the last step potential. So this is the same equations. This time the difference only is that the V naught potential is between 0 and A only. And after that we will get the 0 potential again. So for x less than 0 it will be 0. For x greater than A it will be 0. And for x 0 to A it will be V naught, the potential. So let's write the equations. First, classically, if we consider the particle, and for energy is greater than V naught, then there will be some momentum here, some momentum here, some momentum here. So momentum will decrease with increasing potential. So P1 will be under root 2me, and for 0 to A, momentum will be 2m E minus V naught, because total energy will be E minus V naught. And for the third part, it will be under root 2me. It will remain same as the first. So these are the momentum of the particle classically. Now if the particle has greater than energy V naught, then it will just transmit, means there will be no reflection. So it will be total transmission in this case. Now if we want to write the Schrodinger's equation, means quantum mechanically we need to write the equations for this thing. So let's write the equation. So Schrodinger equation will be, for the first reason, it will be d square psi 1 by dx square plus 2me by h square psi 1 equal to 0, just like in the last case. So we'll denote this with the k1 square, so it will turn out to be this equation. For the second reason, total energy will be E minus V naught. So this will be your, because E is greater than V naught, that's why we have written E minus V naught. So this is your Schrodinger's equation for second reason. Now we will write this as K2 square. And the third, it will remain as the first, so it will remain same. Now we know how we find the solution of differential equations. So for this one and this one, we'll get this kind of solution. A exponential I k iota k1x plus B exponential minus iota k1x. And for the second one, it will remain same, just the coefficient, means these coefficients will change, C and D. And for the third one, see, there is no reflection can be possible here in the third reason. That's why we have only the transmission, means there will be no reflection wave. So only the transmitting wave will be there. So that's why we'll take E exponential I k1x. These just representing the direction, means plus k1x will representing the wave going in this direction, and minus k1x will representing the wave coming in this direction. So these are the two, and here also they are both two are possible, going this side and going this side, but here only this wave will be possible. That's why we have only one coefficient. So now you have the three solutions for the wave function. Now you can find the, means also now we can find the probability also of finding the particle with the wave. So we know how to find the probability. In the last we have did, so psi 1 star and psi 1, the product will give you the probability, and that will be psi 1 square. So this will be give you a1 square a square plus b square 2ab cos k1x. And same for the psi 2, it will give you this. For psi 3 it will be this. So if we plot the probability curve, then it will be sinusoidal because of this cos term. So psi 1 in the first reason will give you this kind of curve, probability curve. For second will be like this, but this amplitude will be little low because of the less energy. And in the third it will e square, means probability remain constant. So many times this is asked in the paper exams, that what is the probability curve and how. So that's why it is important part. So you must remember this. So this is how the probability will be there for the potential barrier. Now we'll apply the boundary conditions to find the transmission and the reflection coefficient. So we don't need to go into the very much calculations. It is just the same as we did in the last. So but the things which are important I will tell you. The boundary conditions will be, at this point the psi 1 0 and psi 2 means psi 2 0 must remain same, and at this point also psi 2 and psi 3 must remain same. These are the boundaries, and their differentiation, the first order differentiation will also remain same. So phi psi 1 0 psi 2 0 equal, and d psi 1 by dx 0 at d psi 2 by dx 0 will remain same. Similarly psi 2a and psi 3a will remain same, at a point, and their differentiation also remains same. D psi 1 dx a and d psi 2 by dx a will remain same. So you can write it that also here. Now you know what is the current density, so you will find the transmission and the J incident as we did in the last. So T transmission coefficient is simply J transmission divided by J incident. It will give you E by A square. So we have did this calculation, that's why I'm not explaining again. This is just a waste of time. I will repeat that. So just watch the last lectures. So reflection will be J reflection divided by J incident. So it will give you B by A square. And only this thing is important. You must remember this thing. And in the last result will be T is equal to 1 plus 1 upon 4 k1 square minus k2 square divided by k1 k2 sine square k2 a and the inverse of this whole term minus 1. Now if I define a term that is epsilon that is nothing but E by V naught. E is the total energy, V naught is the potential. So for the epsilon greater than 1 means E is greater than V naught, then there will be transmission will be approximately 1, the probability, and reflection coefficient is tending to 0 because sum of this T plus R must be 1. So for this kind of situation, when energy is very greater than V naught, this will T tends to 1 and this tends to 0. Now when the energy is approximately equal to V naught, means not greater, it equal to V naught, then T will be defined as 1 plus ma square V naught by 2h cut square inverse. So you must remember these terms. The question can be asked directly from here. So this also can be written in this form, 1 minus k1a by 2 square and the bracket close. So you must remember these formulas, only the important things I have mentioned here. Now let's go to the next case, that is when energy is less than V naught, because we have considered the greater V naught and approximately V naught. Now the tunneling will occur when the energy is less than V naught. So let's see that case. So this is the case 2. E is less than V naught and we will study about tunneling here. So again now we need to write the solution for these equations. So first equation will remain same, but in the second equation see this E minus V naught will turn out to be negative because E is less than V naught. So this will be minus k2 square psi 2 equal to 0. So that's why we will get the solution of the psi 2 will be like no iota will be there. It will be c exponential k2x plus d exponential k2x. So this will be the solution because this will be negative this time. So we'll get these three solutions: a exponential I k1x plus b exponential minus I k1x, and here no iota is here. So psi 3 will be e exponential I k1x. So now again k1x square is this, we need to mention this, k2 square is this here, and again solving we'll get reflection coefficient as b by a square and t as e by a square. So and the probability curve will be like this. For the first region it will be sinusoidal, in the second it will means this is the exponential term will be valid here, so only this will affect the things. So psi 2, when you do the probability thing you will find the psi 2 star psi, this will give you exponentially decay, means we have discussed this thing here, that how we get this kind of curve inside the barrier. So that is the same thing we are getting here. So now this time you have make this finite. So because this is a potential barrier, so this probability is gonna decrease, but it is not going to be 0, and the barrier will be stopped and you will be in the again 0 potential region. So means the particle can be present here also, means particle will transmit, and this process is called the tunneling. So and you can just define it here. E less than V naught, then transmission coefficient will be 16 E by V naught 1 minus E by V naught exponential minus 2a k2, where a is the this distance and k2 you know what is k2. K2 can you find it from here? And the important thing is you can write this transmission coefficient will be proportional to exponential minus 2a k2. So you can just see that this will be greater when this a is greater. When this a is greater, then this t will be lesser, means there will be less probability of transmission. When this a is large, this distance is large, and also if the potential is large, potential barrier is large, this will also decrease. So I have already explained this thing in the previous when we are discussing the step potential. So now the one thing I want to mention here, so you know the importance of the tunneling, that you know the main thing happens in the fusion, nuclear fusion, is that is tunneling. Means in the sun when we get the energy is due to the two hydrogen atoms will tunnel each other, means there is a potential barrier between them because of Coulomb potential, so they can't interact, but still they got inside each other and they got fused to make helium. So that is only because of tunneling, because only then they can just make that barrier of energy, means they don't have that sufficient energy or they can't just move the Coulomb potential. So there will be potential barrier, and there is this not sufficient energy, but still they are fusing together. That is because of tunneling. So that's how the sun gives us energy. So there is the tunneling very important for our existence. So that is the importance of tunneling. That is for today. In the next lecture, we will discuss about the infinite square well potential. So thank you everyone.